everybody. My name is Ian Cooper. So I'm here because I'm the kind of person that talks about messaging. And
Yeah, so my name is Martin Thwaites. I go by martin.net on socials and stuff like that. And I talk about observability and OpenTelemetry and all of that kind of stuff. And I think it was about 6 months ago, Ian was, I can't remember where we were at, one of the conferences. And Ian came to me and said, I want to do some talks around messaging and observability. Can you help me with some stuff? And I went, you know what? Why don't we just do it on stage together, and then you can all just be in while I train him, my new junior dev.
you may wonder where the other member of ZZ Top is, but we're trying to basically increase diversity of the conference by having two old white guys with beards on stage at the same time, which is working really well.
We have diversity of beard length.
That's true. And you've got some ginger in yours.
Cool. Right. Okay. So we're here to basically marry the two ideas of event-driven architectures being complicated and observability being something that allows us to understand systems.
So, somewhat ironically, when we were building the demo for this, I was essentially thought, hey, it's okay, Martin, I've got an idea for a demo app. I will go and build that, but you can just add the observability later. We thought we could just really end up doing a talk about how painful it was to try and build a messaging app without any observability turned on so that he could turn it on later, because we probably managed to successfully prove every point we're about to make in this talk. And we'll kind of refer to that as we go along, kind of how that it was illuminating that we just struggled in exactly the way we predicted.
It didn't work.
My code is fantastic. I just left a few things out.
It didn't even work on his machine. So, do you want to start by talking a little bit about flow and complexity and why we're here?
Like the conch. I have the conch. Right. Okay. So when you first start out learning to do messaging between systems, you're building something with Azure Service Bus or Kafka or SNS and SQS, you get to a relatively simple point of complexity, right? You've got your producer and you've got your consumer, your sender or receiver. It doesn't really matter on the words. Okay. But even at this point, there's quite a lot to go wrong. So when I'm writing my receiver, typically I'm going to have some kind of message pump. And the message pump is going to take a message off the wire, it's going to translate it, and it's going to dispatch it to some code that handles it. And there's pain there, right? Am I reading stuff off the correct place? Can I actually read stuff successfully? When I get the message, can I translate it into something that could be expected? When I dispatch it to a handler, is it going to the right place? Does it succeed or does it fail? So even that simple idea of a loop has quite a lot of complexity in it. And when we were writing this demo app, Martin kept saying to me, Ian, the bit of code that's supposed to notify us about the status of the delivery over Kafka doesn't seem to be working. And I can't figure out why you're getting this piece of these messages all about type information, etc. And the problem was I'd completely forgotten to put in the bit of code that translated the body of the message into a type in the type system. Just had slipped my mind. I've written 1,000 messaging programs, right? So it's really easy to make mistakes. And the problem is there's a whole world of how do I figure that out, right?
And what was interesting about that, though, was the error was happening inside of a mapper. So the code where we were trying to say, why is this not being reached? Or why is this not hitting the database and updating something? Is you put a debug endpoint, a breakpoint in there, and it wasn't even hitting the breakpoint. And it took actually adding some telemetry in there for us to notice that it was actually in the mapper that it was failing. Because a debug wasn't seeing it. Because we didn't know where to put the breakpoint in order to be able to see it. This was one of those situations where we got to the point of going, well, I might actually need to add observability and then remove it so that we can do it for the demo.
So one of the reasons this becomes a bit more complex is typically it's a bit more of a story than this, right? So you tend to be doing one or two things in messaging. So the top model, we tend to call a kind of in-only pan. So you can think about that as fire and forget, just sending a command to someone as an instruction to do something. And quite often we stop talking about sender and receiver or producer and consumer and start talking about requester and provider. And that's because one team is essentially providing an API that another team is calling. So on an in-only model, the team who's providing the API usually owns the message pump. And they're essentially saying, there's a series of operations that I expose and you can call. When we talk about out-only, typically the team providing the API is the producer, and they're essentially doing a pub/sub. They're literally broadcasting it to everybody. And there are problems because typically that's often two separate teams. And you may be divided by time. Martin was at one point when we were trying to work on this together effectively on a plane and in the US. You may be divided by cultural language. Martin comes from up north. Right?
Where we speak properly.
So it can be difficult to interpret him. And those things make it hard because if I own the provider and Martin owns the requester, how does he know why something is failing? And often he doesn't want to spin up my app and start debugging it, right? And this is the problem we hit quite a bit, is saying, okay, I need to actually load your app. I need to start debugging your app. How do I load your app? How do I debug your app? How does that actually work for me? And the same with out only, right? The problem I'm going to get is someone's broadcasting a message, but I say I don't really care whether anyone listens to it, but is anyone listening to it? What happens if I'm sending it to entirely the wrong channel? It's just a name that I've configured somewhere. In our case, right, we're using the local emulator for Azure Service Bus. So there's a config.json file we typed a whole lot of names into, and we retyped those names into the code for the request, and we retyped those names in the code for the provider. And that's really possible we're going to make him mistype those. But that's really hard to figure out, right? You can sit there staring at the screen for hours wondering, why are my messages not going to the right place? And it's really hard to determine what happened if they did.
And there's no amount of unit testing, there's no amount of putting tests in your code that can test for configuration things like that. These are names of queues, names of topics that go in a config. When you go live, it'll be different in your staging environment, it'll be different in your dev environment, your local dev will work one way. And there's no amount of unit testing that you can put in place to say that we've got the right config on there. Maybe it's part of my Pulumi or my Bicep or part of my CloudFormation that gets it wrong. It adds a GUID on the end. Who knows? It's only when it goes to production that we actually start to see that.
And it gets even more complicated if there's not a one-way piece of communication. So when we begin to think about in-out communication, so the idea of a request and reaction, we tend to sometimes say request and reaction rather than request and reply in messaging, just to distinguish the two and try and give an understanding to the asynchronous nature of what's happening, right? There's basically message boxes on either end, and I am sending you a message to do some work, and I am waiting for a reply. That happens asynchronously. I'm not blocking. So I send a message out. Some point in the future, I get a response, and I have to resume an operation. Perhaps I have effectively written something to a database and said, hey, I'm going to put something in a database, and when you get the response back, I want you to retrieve that. In our case, to simplify our lives, we were using channels inside basically the application, which is sitting there waiting to pick up a response and fire it back.
That was its own pain, just using .NET channels because, well, they're not instrumented either.
And so it becomes very difficult in even this simple interaction to understand what's going on, right? My code has not received a response. Why? And we typically use got a correlation ID. A correlation ID effectively is we're saying there's an identifier for this particular exchange, right? So I send you something and I reply back. The way to think about it typically is when you old school send a letter and you would put basically my ref, your ref, right? So that you could actually correlate the things. But there's no good way for you to really understand anything other than I've sent something with an ID. I didn't seem to get a response back with my ID. What happened? Right? There is no way for you to do that as the sender, and that's very disconcerting, because how do I know what went wrong? Did you never receive my request? Was there a failure to send? Or is it just a failure for you to reply back and for me to receive? And so although we have a notion of a correlation ID, there's nothing here essentially letting us see the actual flow between these two areas. And as we say, it's a problem of complexity that increases with the more teams you have working on it, the more people you have working on it. It's the kind of nature of distributed systems. They're very uncertain. People start working with this kind of code, they find it very unsettling because they don't get to essentially just debug the whole thing end to end in a line. There's a problem of distance and a problem of time that is now hurting them. It gets even harder if actually we begin to also think about compensation style flows, right? So I ask you to do something and you can't do it, but what you've made a promise to me is that you'll tell me you can't do it. I want you to take a payment for this customer's shopping cart. Oh, I couldn't do that. The customer's car basically was refused. Because it implies I now have to basically await two possible flows on my side. And how do I understand what led to those different reactions?
And now, if you look at this at the moment, you're probably we've gone through a few different of these strategies. A lot of people don't think about in-out. They think about pub-sub. They think about queues and topics. And that. All of this is confusing, and we're only talking about one single interaction. When we go on to something like that, all of those non-linear lines, those little dotted lines that are going around, all these different interconnections, it gets scary. I'm from a world where I am used to a nice distributed monolith. They're great because you can, hit the thing and it hits the thing. It's great. But not only are those interactions happening when I don't know because they're on a schedule, they're polling and that kind of stuff, some of those are happening at the same time. We've got race conditions.
So what you're looking at here is we decided to build a sample app, and some of you know I work for Just Eat Takeaway, so we decided to build a simple pizza shop. It's a pretty classic example.
The 1-minute pizza shop. All of your pizzas are both cooked and delivered within 1 minute.
And due to some limitations in Ian's coding, we can only offer to serve you one pizza at a time.
Yes. If you order 3 pizzas, you don't get any of them.
Yeah. A slight bug. But you can see here we've got something called the storefront. So the storefront, effectively, the idea is it's just really an HTTP interface on one side that takes an order, and an HTTP interface on the other side that lets you query for the status of your order, right? And that talks to basically the pizza shop, which is that kind of middle one. And the point of the pizza shop is to essentially cook a pizza and to effectively arrange for a courier to come and collect it. And then we've got a courier at the bottom who's basically going to respond to the pizza shop and say, yeah, they're available, they can come and collect it, or pick it up, and then they will report their progress back to the store. Now, I can promise you, this is a very simplistic version of what actually happens in reality at somewhere like Just Eat Takeaway, and I imagine our competitors, and yet this is pretty complicated when there's just two of us working on it and trying to figure out what the hell is happening and what's going wrong. So you can see there are both points of interaction, those dotted lines, and then the sequences flowing in between. Those points of interaction is where we're effectively doing some kind of messaging. So typically, if it's between the front end and the pizza shop or the pizza shop to the courier, we're going to be doing messaging, and it's going to essentially be done over Azure Service Bus. And where we're effectively broadcasting events from the courier, we're going to be using Kafka, and we're going to be doing events.
And that's basically what your architects will have given you and gone, go build that, it's simple. It's not simple.
So mine's going to queue up, and we're going to show you a little bit of the code. We're not going to run it as yet, deliberately. You wouldn't see very much because the point is all you'd be able to see visibly is I make an HTTP call and I get a response. But a tiny bit bigger, mine, for the folks, I suspect.
I'm going to... Let's just...
We just want to give you an idea of what that kind of takes. And remember, this is just a demo app, right? There's nothing here that... And your real-world app is far more complicated. So if we go and have a look at the storefront, we can start there. just a minimal API, and that message there at the bottom is the key one you want to. So we've got an app.map post, and the app.map post will post in the orders. There we go. And the app.map post simply says, take that HTTP request that I got on the wire, and we're going to post it over to Azure Service Bus. You can see that we're pulling some config out, right, to tell us basically where to find the service bus, tell us what the name of the queue is that we're talking to, and we're just going to push something out, right? And all that happens is we just know at this point we've sent a message. But there's not a lot else going on other than we just know we've sent a message. So if you hop over to the pizza shop, so that's fairly simple. You're going to have the program file for pizza shop. This code's on my GitHub, by the way, so it's GitHub Keeper. You can go and look. You put the program file for us, Martin, on that one, I think. You can. That won't show us very much. But what we are creating here are a number of background services, and those background services represent message pumps that are effectively listening to order service, listening to responses from the courier, and we're also going to post it out. So as an example one, let's go and have a quick look at the kitchen service. So when we get an order in, we're going to send it to the kitchen service, and the kitchen service here is effectively going to cook our pizza, and essentially it wants to effectively, so it's waiting on a channel internally on .NET, and that gets signaled, we'll show you that in a second, by us receiving a message saying here is a pizza, and we're then going to wait on receiving a message from a courier to say that they're available after we send them a message saying, are you available, right? So if we quickly look at...
You will notice, by the way, there is some instrumentation in here because it was way harder to remove the instrumentation, and I didn't want to because then it might break and I might not know what's
So if you can imagine, we were trying to debug this code without the instrumentation. It was getting particularly hard. So I believe if you go and look at the order, go look at delivery. A delivery request will do us for an example one to show. No, delivery service factory one below. I think it's the one, and then dispatch service one below that, actually. Yeah, that's the one. So dispatch service effectively is the one that we call from the pizza shop when we begin to cook. And what we're saying is, hey, I want to send you a message to determine effectively whether or not you have a courier available for us.
Sorry, I wanted syntax outlining, and
okay.
Code didn't like it.
And the other one, if you go and look at the order service factory, no, I can't remember the name of the actual service that we need to go look in the order service factory, right down the bottom, above pizza. Yeah. So this one is what's listening to a message from Azure Service Bus and saying, hey, there's a request here for you to cook a pizza, and it puts a whole set of messages out, basically, as a result of that. So the place order handler, if you just go into that, Martin, a little bit further down, yeah, you can see here it's going to write some messages, one out to basically a cook request, one to a delivery request. So it's in parallel saying, cook the pizza and figure out whether or not, basically, we can get delivery, right? And if you then go over to the last piece, which is to go to the courier. Courier should be fairly straightforward. Yeah, if you go to that one, you can see we're receiving the message saying, are you available? And we run a handler, and the handler says, okay, we've got a little flag that can reject a job, saying I'm going to accept the job or I'm going to reject a job. And then we've also got a Kafka service. Yeah, go on that one. I'll tell you where to find it. All right.
Which one are we going on?
You want to go to the delivery service factory, I believe. And I'll tell you, delivery service, yeah. The delivery service is going to work with Kafka, and it's going to produce a message updating the status of the order. So we just use a simple mechanism of a time elapsing to say, should have arrived, and it sends you on the way messages or a delivered message.
So I'm guessing all of you know exactly how that flow works now. There's a test in, 1 minute?
So we kind of deliberately did that to you, and it's a bit mean to walk you through the code, and it's a bit confusing. But the point is, we are hardly doing anything, and yet it's really hard to figure it out, right? Even with the source code in front of us, with a whole lot of jumps between applications based on messaging, a whole lot of channels firing off, asynchronous work, it is difficult to understand. We wrote it, and it's difficult for us to navigate our way through.
I still don't understand half of what's happening in there.
Right. So and that's a puzzle that you're going to get in reality, and it's a puzzle that gets worse. So we don't want you to, if you want to go and have a look at the code, feel free, it's on GitHub. I wouldn't build your entire new business model based on it.
I mean, if you do, we want a cut.
I think James has got a pizza shop of his own, down the front. James did say he's worked really hard on his, and you could possibly run a pizza shop on his one.
So a lot of this is intentionally unintentional errors, and some of it is unintentionally intentional errors. Because a lot of this was, I mean, I don't know how this is going to go when we actually demo this, by the way. It does work, and I can add instrumentation to it, and you'll be able to see how things evolve. But ultimately, I still don't know some of the errors that are happening in here. And we've spent 2.5 weeks building this demo. That's how hard this thing is. And it's 3 services. So the front end, a pizza shop, and a courier. That's all it is.
And what we wanted to do is move away slightly from the problem with these kind of demos that you see in these kind of talks, which is A talks to B. And the problem with A talks to B is it's not a realistic situation, which gives you an idea of I'm struggling with uncertainty, complexity in both time and effectively distance between my application pieces. All right, should we flip back to the slides?
Yep.
All right, so before we get into the kind of conversation about observability, there are a couple of other things that you should kind of think about and know, and a few little things that you can do statically to try and help you with those problems. So the first thing I want to just talk about a little bit is the separation between orchestration and choreography. You'll see a lot of people talking about this being, oh, it's commands versus events. I'm here to tell you that I think that's nonsense. So really, what we mean by orchestration is as follows. Something is managing that workflow. Typically, something is maintaining the state of an instance of the workflow. There's a technical term in process automation called a token. A token is the idea that I create an instance of this and state moves through the sequential flow. But on this diagram, the thing in the dotted line represents effectively a process, and it represents something we're controlling with some choreography, with some orchestration. Orchestration could be embedded in your app. Right, so you could take something like Mass Transit or Brighter, write a bunch of handlers, and they say, hey, my code responds to a message, my code responds to a message. And you don't have to have an explicit state machine or explicit workflow, but you're still effectively running things in sequence, saving stuff to the database, effectively resumable. It could be more explicit. It could be a state machine like Stateless. It could be a workflow product like Workflow. It could be an external thing like Carmundi or something like that effectively you're using to manage that orchestration. The choreography is the bit that nobody's in charge of. And that's all of these messages flying between the things that are orchestrated. And that's a very technical definition of the difference between choreography and orchestration. So a bit of clarity, some color. Martin and I are quite lo-fi on our slides. So a little tiny story is that I gave a presentation and somebody in the audience was tweeting saying, my God, Ian has gone with this brilliant idea, this faux 90s aesthetic slide. I expect to see more of these callbacks to the 90s. And I'm like, wow, dude, I just drew plain slides with some a few diagrams on it. But the idea here is that is the wrong way around. Wow, it's the wrong way around. The orchestration is in gray and the choreography is in blue. There you go. So, and it gets more complicated once I think about errors, right? So compensation is this common idea when I'm thinking about essentially some kind of orchestration. So here you can see the idea of, hey, what happens if I don't get the delivery of my food? There ought to be some kind of time limit, at which point essentially we say, okay, maybe the courier got lost. The pizza's probably really cold. You wouldn't want it by now. We should redo that order.
We're not expecting you to look and read all of these individual boxes, by the way.
No, yeah.
If you squint, you can see the complexity.
That is the idea. The idea we want you to focus on is even a tiny little noddy thing like this is accruing quite a lot of complexity about how we think about it. All right. Even worse, and again, don't bother to read the detail, in many cases, that includes places I work at, right? People don't think clearly about orchestration versus choreography. What they do is essentially just randomly slice something up and say, this team owns this bit, this team owns that bit, this team owns the other bit. So here is a kind of typical example that I might see where effectively what was previously shown as a single orchestration is in fact 3 partial orchestrations of the same piece. One piece dealing with a kind of receipt of the order, other piece dealing with cooking, other piece dealing with kind of managing that courier journey. And the problem with that is that I enter a real world of uncertainty. I have very little view of what is going on. There is not much orchestration at all. We tend to refer to this problem as pinball. The idea essentially that I pull back the lever on my message and I fire it, stuff lights up around the system, but I have no real idea why. Right? It's just like firing things off a pinball machine. And that's a real anti-pattern for complexity in event-driven architectures. This idea that effectively I just don't know what's going on. During an incident, someone says, what happens if that message doesn't get sent? And nobody knows the answer to that problem.
And I think this happens way more when we start thinking about serverless scenarios, as your functions triggered off service bus, or off event hubs, or off Lambda with SQS, and all of that kind of stuff, because we've made it easy. People like Maddie have made this really easy to build these things with Aspire, but they're really, really hard to maintain. They feel easy. So I've got 15 functions. I just deploy 15 functions. And it's good, right? Because they just all auto-scale. 0 to 1,000 in less than a second. Great. It's amazing. But I don't need to support it, so that's OK.
Some of you may remember Amazon Prime Video. Amazon Prime Video issued a blog post which got mischaracterized as the death of microservices. But really, what they were talking about was the fact that they had essentially broken up a single orchestration into a number of tasks using essentially AWS step functions to coordinate all those tasks, and realized that it added a lot of complexity, and really they just need to do the orchestration in process. But you have to think about these things because they do add a lot of complexity to your system. All right. So we'll talk a little bit, first of all, before we get into some of the telemetry. I just want to talk about what tools are available to you to try and understand the system in a more static sense. So this, again, don't try and read it because it's not that valuable information. But this is a YAML file. You can use JSON as well. But this is async API. So for those of you who don't know, async API is the equivalent of open API in the messaging world and lets us document our endpoints. So what happens is for a given application, I will say, I receive these messages on this channel, or I send these messages to this channel. You can document the channels, the queues and the streams that you have, and you can document effectively the schemas that go over it. But there is no information that tells you as part of this what's the connection between a message that I receive and one that I pump out. There's no sense of flow. There's no sense of how the thing operates together. We could be really old school architects like me and go into BPMN. We're not going to teach you how to do BPMN. I just want to show you what it looks like. So the idea here, I start an event, I've got a task, I've got an event that I wait for partially through. In response to that event, I may launch some tasks, an either-or choice. I get back to the result at the end, right? I could go and document them all. Here is effectively me reading some information from a basket, pricing it, looking for vehicle delivery. That's basically an orchestration. And that's what a choreography looks like in BPMN. The key thing is not to really for you to understand that, right? Because that's what it looks like for our pizza shop. The trick is to understand there are tools, but I don't know the extent to which many of you would go, I look at that and I know everything there is to know about your demo, Martin and Ian, and it's all become suddenly clear to me.
I saw that in the slide deck. And now it's up there, it looks terrifying.
It does. And not everyone in your team is going to, even if you learn how to draw these, not everyone in your team is actually going to understand how to read them.
And most of them won't even open them.
Yes. This, just for that simple thing that Martin and I have built, this is the choreography. This is the flow of messages going through the system and what's happening. So it's complex and it's difficult to get your head around. A simpler tool you might be able to use, this is just simply sequence diagrams. Sequence diagrams can be used to show basically the process model interop. So that's slightly simpler. You may have slightly more of a clue at this point as to what is going on. It may not actually reflect that reality. Because
It probably doesn't. 'Cause he wrote that before I came back on the flight and fixed everything.
So, and that is one problem. I mean, joking aside by mine, the problem with these diagrams is people write them and they don't maintain them. So, because they are complex and expensive. And as a result of that, what happens is that you've got something that is very out of date and may mislead you as to what is actually happening. I don't know, maybe you folks are better than us. You keep all your documentation up to date. Everything is constantly right. But for most of us, the running system is the only truth.
Yep. Sorry, we can't merge that PR yet. Nobody's updated the whiteboard to say that that new service has been added. Sorry, we need to block the PR. Okay, so this is the Martin portion of the show. Because if you may not know, but yes, I do talk about something called observability. Now, observability isn't new. So what I want to talk about is modern observability. Observability has been around for thousands of years. Back in the 1500 BC, they were carving dashboards into cave walls. Just regretting that moment, like when they ask, "Can you add auto refresh, please?" I jest, but observability is the idea that we need to understand what's happening in a production system. This isn't new. We've been running production systems for many, many years. I'm not going to tell you how long I've been running production systems, but the year started with a 1. So it's not new. What is new is all of those diagrams that you've just seen. These things, all of these. The systems that we're building are way more complex, which means we need to think about how we observe these systems differently, and that's where modern observability comes in. Obviously, it's all
thinks of me as the guy basically sitting, staring at the carvings on the wall. But yeah, go on.
That is Ian, by the way, about 40 years ago. Obviously, it's all about 3 pillars. Yeah, just all you need to do, just put some logs, put some metrics, put some traces in. Job done. We have observability. Yeah. No, there are no pillars. I talk about this a lot. I rant about this a lot. There are signals. We have signals which give us data. They don't give us insights. They don't tell us something. We use that data to find things out.
But Martin, we put a Spire in our app and we turned it on, so we've got telemetry. Is that not enough?
It depends who you ask. Is that enough, Maddie? Yeah. All right, okay. You'll see why it's not in a minute. Observability is not about generating signal data. That is not what it's about. It's also not about monitoring. It's not about putting in place a check for something that we know is going to happen and alert us when that thing happens. That's monitoring. We can use the same data for monitoring and observability, but they're not the same thing. Observability is about understanding. It's understanding your context. And to do that, custom instrumentation is the key. When we talk about custom instrumentation, it's not one thing. I'm not saying that you need to add spans all over your code. Custom instrumentation is about taking your context about your pizza shop, about your e-com platform, about your energy provider platform, adding that into your telemetry data so you can ask questions about the flow. Not that there was a message that went through here. What were the key characteristics of that message? So that we can understand which message failed. What was in that message? Well, we sent 3 pizzas, and that's when it failed. Not there was a pizza message come through and it failed. If we add, this is a real thing, by the way, this is Aspire when I added auto instrumentation. It's great. You know what's great about it? Because you can make fun things out of it. That's literally, I posted that internally on one of our Slacks at my company, and somebody came back with that, so I had to show you.
That's Tommy and the Tiger in Norway, not Calvin and Hobbes.
But ultimately, they're not useful. Like, great, I've got data. I've got that signal data. I've got a trace. It goes all the way down the thing, look. It's not useful, though. It's not going to give me understanding of my production system. Too many times what we end up with is people just throwing loads of signal data at their back end, whether it's Honeycomb, where I work, or Datadog, where James works. They'll throw data at it, and now they have observability. This is why I don't talk about 3 pillars. We talk about the right amount of data for us to gain insights. That could be metrics, it could be logs, it could be traces. We're going to focus today on traces, because in a distributed system, the causality is what's important. Being able to see how all of these things interact, all of those dotted lines that you saw in those diagrams, that's what's important. There is not one time where your CEO is going to come round to you and say, Ian, I know we've just had a £4 million an hour outage, but I really like your diagrams. They're really cool. Nobody cares.
I dream of that moment, Martin, you know that.
But nobody cares. Now, in this particular example, and this is a small example, we've got HTTP calls, we've got .NET channels, we've got Kafka, we've got a database in Entity Framework. Pro tip, by the way, if you're doing things locally, don't use Entity Framework in memory. Use Entity Framework SQLite with an in-memory database. Specifically because you'll actually be able to see the database interactions, because otherwise it just happens in memory on the objects and none of the instrumentation works. And it's way more valuable to be able to see what that instrumentation is. When you've got something that hits 17 database calls, when it should really just be doing 1, you won't see it.
We had, a certain amount of problems just with the yak shaving stuff, right? We're trying to effectively get to the point where we can debug some of the messaging interaction that's failing, but we've got yak shaving problems with just getting Entity Framework core right. And being able to eliminate that stuff really helps you, because it can help you move forward to focus on what you want to focus on, which is what is the flow of my application and why is it not working? And
okay.
Literally was not working.
Right. So, let's see if this works. If the Aspire portion fails, then I'm going to get Maddie up here to come and fix it. Okay, so what I'm going to do first is we are just going to add the default instrumentation. So this is just running an Aspire app host, hopefully. Maybe. We'll see. Now I need to work out whether my service bus is running. I hope it is.
So we are using the local emulator for service bus, which is
lots of red.
A journey across Mac and Windows that we were doing together. It turns out that Mac and Windows don't like all the same things when you're trying to build a demo app to get together. My Mac didn't, with running Podman, didn't particularly like SQL Edge. Yeah.
Journey is an accurate description. Right, so let's run a request against the API. Oh, yes. It's paying off.
You don't know how long it took us to actually reach that point. The reason Martin's so excited is it was both of us, I think, almost destroyed laptops. I think he almost had plane rage.
The door nearly came off and the laptop was going to go out on the door. Okay, so basic instrumentation. This is new project Aspire. Here's some distributed services. All we're doing with that is I've got this telemetry extensions in a shared repository. Did you know you don't have to call everything service defaults? You can call it whatever you want. The amount of times where somebody's, oh, I have to call it service defaults or it won't work. Like, it's just a project, dude. So what we're doing is we are adding the OTLP exporter, which is what we need to send it to the Aspire dashboard. We're giving everything a name. So every unique thing has a service name. That's a OpenTelemetry semantics. We're going to enable tracing. We're going to get it to listen to a custom source, a custom tracer, which has the name of our service. I'm going to add the default ASP.NET Core instrumentation to all of them, even though they're not using it. It's not a problem to add ASP.NET Core to something that doesn't have ASP.NET Core. It's fine. We're adding Entity Framework Core instrumentation, even though they don't have it. And that's it. Now, out of the box, Service Bus does not have auto-instrumentation. It's experimental right now, and you'll find out why, because we found a bug. Another one where I was like, it's not working, why are all these things here? And then I spoke to Lou Miller, who's one of the people on the Azure team, and she went, yeah, that's a bug, I've fixed it. The joys of ranting on Blue Sky is great. So, now...
about Kafka here as well? Or you
I'll get on to Kafka's its own journey. So let's enable the experimental Service Bus work. Now we get to work out. So I was just talking to Maddie earlier. Now I've just stopped Aspire, and now I've got to fill for an indeterminate amount of time while Aspire spins down in the background so I can restart it. Please fix that. Please fix it. I lost a day on that.
I like to think Maddie's actually coding the fix over in the corner while we speak.
I can just imagine it's like, yeah, can you just do .NET add package and pull down the new one, it'll work. Please do that. Okay, so, that's all down.
So one of the things, is everyone familiar with what we mean by a trace?
Anybody not familiar with a trace? Come see me after class.
Right.
Okay.
Just want to make sure, because sometimes, we don't want, if it's the first time you met some telemetry concepts, we want to make sure we don't skip over that.
When we go through one of the ones that actually makes sense in a minute, I'll explain it a little bit further. I don't know what those failures are. I haven't debugged those. I'm presuming they're not important.
So that's basically Kafka. Kafka's very noisy. So what happens, unless
like
you're
me.
Unless you're running it.
Am I Kafka?
Kafka moans slightly less than you, but about the same amount. So Kafka effectively runs, unless you're in Java, on a library called libid Kafka. Libid Kafka effectively is a C-written library, and it's used by all the clients in Go, .NET, etc. It is noisy. It will tell you a lot about errors, where effectively they don't bubble out of libid Kafka to your application code. They're just inside, and it will tend to handle it. There's a flag called fatal errors, which you can basically pick up, so you can use to reduce the noise. And typically in production environments that I've worked in, that is one of the first things everyone does, is to basically try and suppress that noise, because otherwise all the operators are going, why does it say scary things to me, like I can't connect to localhost 9092 for the Bootstrap server, and it's polling in a loop until it comes up. Right?
So there's going to be a theme that you're going to notice as we go through this. Tracing is about causality. It's about this thing caused this thing to happen, or this thing caused these 5 things to happen, and those 5 things caused these things to happen. There's a term in OpenTelemetry, or more specifically in the W3C specs, called propagation. And it's how we propagate between process boundaries. So we've got a pizza shop, a storefront, we've got some couriers. They're not in the same process. There's no way that you can have a static in your code that transmits all the way through those. A message goes up to Service Bus, somebody picks that message up. Now, one of the problems that we're seeing, this is a trace that hits the post orders endpoint. You can see it up there on the top left there. Let's zoom in a bit. I do like that Aspire, by the way. You can zoom in. It does actually work. It's very built.
It looks really pretty, doesn't it?
It's very built for demos.
It makes the application look beautiful.
So what we're seeing, we're starting to see, we've got a post to our order service. We've got some database calls that are being made. We've got a Service Bus call that's made from the storefront. And you can see that the pizza shop picks up that message and does something. Now, if I go back to our list of traces, look at all this noise. One of the problems that we try to do with telemetry is remove the noise. It's less noise, more signal is the term we use. What we want to do is get rid of anything that isn't important. Now, what we can see here, though, we've got this other one here. We've got another one here where the pizza shop is processing a message, and it's sending it to Bob Availability. That's one of our couriers is called Bob. And then we've got the courier picking it up, and then that's doing some Service Bus stuff, and it's doing some more database stuff. But they're not connected. Should they be connected is a different question, because there is way more art than science when it comes to observability.
When we're building this, I had to hop on a call with Martin to look at this because I couldn't figure out what it was telling me about why things weren't working. And Martin was like, I can fix it. I can fix the telemetry so you could understand what the hell is going on, Ian. But it's a problem, right? That there's a lot of signal to noise at that point.
So all that did is it turned on these special flags. So app_context.setSwitch is a new thing in Service Bus that adds some activities around stuff. It is not foolproof right now. That's why it's called experimental. Don't go complaining that it doesn't work. Got experimental on it. So, and then we tell OpenTelemetry that we would like to listen to this stuff, and it does some interesting things for us. But we've still not got a load of stuff. Now, this is where it comes into us using channels. Channels in .NET allow you to put an object in a place, and then something else, some other thread, comes and picks that object up, which means that we've not got that propagation between those. Service Bus works fine in some ways, but channels doesn't. So then we had to come up with a way to make that work. So all of our requests now have all of this. I created a base object. So what happens is whenever we new up our traceable request, of which all the stuff that goes into channels derives from this object, it will automatically add our propagation context, something we've had to do manually, because there's no way to do that in .NET. So we've added that in. What else have we added? So let's turn on custom telemetry now. That one there.
Kafka? We're doing Kafka?
Yeah. So Kafka was a really interesting one. The Aspire Kafka instrumentation, if you use the Aspire Kafka packages, only adds metrics. It doesn't add any kind of tracing context. It doesn't use the standard OpenTelemetry libraries for any of this. It uses something built specifically into Aspire. So we started using the standard OpenTelemetry packages, which caused us a end of nightmares.
So one of the reasons for this, as Martin kind of navigates the code, so Azure Service Bus offers you the opportunity to use its own message pump. So the message pump is the consumer code you read to read items off and dispatch and handle. So there's a nice loop you can plug into with Azure Service Bus. So effectively, they can put telemetry in for you. But when we're using tools like Kafka, the problem is we're going to end up writing that message pump ourselves. And so there's no interception point, which essentially is standard, where effectively a third party can go and put that telemetry in for you.
Okay, so I'm going to speed through a little bit more of this, but hopefully you're starting to get this idea. We're starting to add a few bits in there. This is that process message async. That is its own delegate. So within the Service Bus SDKs, when they process a message, they can add their own context and say, when you exit that context, we'll stop it so we can measure things. In Kafka, we don't have that. So in Kafka, we had to add our own. Now, in Kafka, we have a notion of consuming a message. Where are we? In the pump, I believe.
The one you got diagnostics above it.
There we go. So in Kafka, we consume a message. As soon as we've consumed that message, we're out of the Kafka code. But there's no context there. It doesn't know to add a span. It doesn't know to add new context. So we've had to add this bit here, which is this new process message. Now, one of the things I talk about quite a lot when I talk about instrumentation, extension methods. Don't wrap things. Extension methods. So I've added an extension method here to our consume result, which comes back from Kafka, which does manual propagation. Don't be scared. Manual instrumentation isn't scary. Adding a span isn't scary. All we've done so far is add spans. We're going to come on to another bit about adding your own context in a minute. So we're just adding propagation. You can go and look at this code. I've got a ton of talks about how you do a lot of this stuff in your code. What I want you to take away from what we're talking about today is what it takes. The code is complicated. The system is complicated. Don't expect 2 lines of code to demystify all that complicated stuff for you. It is complicated for a reason. And no amount of auto-instrumentation is going to get you to where you need to be when it comes to modern observability.
So one of the things that maybe we should talk about here, Martin, is the fact that, though we might talk about correlation IDs, conversation IDs, and messaging as ways to basically help your app understand the context when it retrieves something, maybe we should mention, how does messaging allow you to connect together separate messages in terms of telemetry? So can we talk tiny bit about trace context?
Yeah, so trace context is something that comes from W3C standards. It's not OpenTelemetry, it's not .NET. In case you didn't know, Microsoft didn't invent tracing. It's been around for a while. They have now embraced it, and I am 100% behind it. It's been embraced in Aspire, and I'm glad that everybody who's using Aspire now is really on board with this idea of using distributed tracing or even just tracing. But it's this idea of causality. I have an action, a context. In this scenario, it's a HTTP message. That's our context. And then everything else happens off the back of it. And it gives us this idea of what causes what. It's not just a linear stream of messages that are human readable. Because you don't do that. And I have asked this question before. Let's see if this works. When was the last time that you RDP'd into a server and grepped the log file? Therapy is available. 99% of people do not look at systems that way. They look at them by looking at structured event data in NoSQL databases. They will run aggregations. They'll run searches. They don't grep logs anymore. If you take that kind of structured data and start adding things like causality and context, start adding your own data to it, you end up in tracing. Spans are just structured logs, but with a load more data that makes them really, really useful. I have stickers that will explain everything.
So depending on your messaging transport, there'll be varying support for putting a trace context header in the message, which enables you to propagate the trace across these hops into various messaging transports. And that's what allows us to begin to see how an overall operation moves, say, from HTTP through messaging, et cetera. Ultimately, one of our goals is to think about how do we want to try and trace through the journey of getting an order successfully to one of our customers.
Okay, so now I've added all the custom instrumentation that I've added. I've now enabled all of that stuff just behind a couple of feature flags. If you really want to go and dig deep into what all of those mean and how they work, go look at the repo. It's not hard to follow, but there's a bit of a learning curve. So now, with all of that stuff in there, you can see we've started to get to something a little bit nicer. We've now got this big thing here. Now, I'm going to have to zoom out because it gets long. Now, what's basically happening here is that same thing that we saw before. We've now connected all of our service bus messages. We've connected all those in-memory channels, all those actions that are being caused and collated, and now in one big trace. But I called it the 1-minute pizza shop. Because what happens is we cook the pizzas, takes a few seconds, and then the courier goes, I'm going to go and deliver it. And then every 15 seconds it goes, I'm in transit. I'm coming. I'm just round the corner. I'm at the end of the street. He's not. And every 15 seconds, it's going to pump out an event that says I'm in transit. And what's going to happen is the pizza shop is going to come up and go, oh, I got that message. I'm going to update my state, update my state, update my state. Now, the astute among you, this big, long line at the top there, what you'll have seen is those 4 messages that are underneath it were originally at the bottom of the screen. Now, one of the problems that we've got is this big process order state, this big line up there, is I'm going to go and deliver something. One of the problems with traces and spans, they do not get exported until they have finished. You don't push out a start and an end. You push out an end that says it started then. And because all the ones underneath it were based on this idea of that's my parent, this is what caused me, but that was missing at the time. Now, you see those things at the top now? You see how narrow they are? Incredibly hard to read. In a HTTP system, we look at that. What's that? That's I don't know. It should be about a minute. But it's about a minute long trace. But the post, the response that went to the user, happened in about 2 milliseconds. Happened really fast. What was it? Sorry, 700 milliseconds. Now, if I think about debugging this kind of system, that is great, I suppose. You know, it shows me the whole interaction. But it's really hard to look at the thing that I care about, which is that post against the API. And that's specifically because this is a 1-minute pizza shop. Has anybody had a pizza cooked and delivered in 1 minute? I don't think so. Maybe a Chicago Town one in the microwave. Was that a minute? I can't. But ultimately, it doesn't happen in a minute. It's 20 minutes. It's half an hour. It's an hour. Imagine that we've got 700 milliseconds and then an hour for the rest of the thing happening. It's not a great debugging experience. When I say there is more art than science when it comes to observability, I mean this. I mean this thing here. Look at your debug context. One of the things that we can do in OpenTelemetry is we control where the context lands. So in our courier service, in this delivery service, I create my span. Because it's channel, so we've got that delivery jobs.reader, reads the orders, the delivery job off, and then goes and does the delivery. This is that periodic timer every 15 seconds. It's going to go, I'm in transit. Now I say just start me a new span. And it'll start me a new span inheriting the context. This thing caused me to happen. I can easily make that an entirely new trace. In OpenTelemetry terms, we have spans, some of which are root spans. Root spans don't have a parent, which means they're their own trace. They're not included in the same trace graph. But what we can do is we can add something called span links. We call these casual links rather than causal links. Causal link means I'm part of the whole trace. Casual links means I'm also linked to this thing over here. So in this scenario here, which is the last one I'm going to show you, what we're actually doing there is we're going to break apart.
So
this is going to fail now, I know it, because I've just done it too, I told you.
This casual link's a bit like what the kids call a situationship. Not really in a relationship, we're just kind of hanging out in a kind of way together.
I've changed my Facebook status to casual link. Yeah. If you do run the demo, by the way, don't stop and start it too quickly because things stay open and you have to just run Docker PS to work out when it's closed. And even then, it's not 100%.
So, I mean, even the trace there that Martin was just showing you was incredibly useful to us when we were trying to debug because for us, a key moment was to get to the ability to go end to end. And every time it would break in that process, it's like, well, why hasn't this thing triggered? Right? And then you can go and essentially look at more detail to discover what's going on. And that was key to us being able to journey end to end, was being able to actually see where has it got to. That is the point we need to actually intercept and see what's gone wrong.
Okay, so now what we end up with, I don't know why I've got 2 in there. That's because I did it too quickly, obviously. But what we've now got is when those things happen, that's still the old one. Did I actually say? Helps if you save the file. Come on, come on. Come on, Kafka. Be a good Kafka. And now the control plane's still running and hogging the ports from my HTTP server. Told you. Please fix that, Maddie.
When I run my messaging course, we only do one example in Kafka because of the pain that is usually involved in all the poor delegates running Kafka.
So what we should end up now is a situation where we have, come on. I know we're getting close to time, or we are on time. So I will say, let's just go back to the slides for a minute.
We are on time, but they want to see the dramatic conclusion.
Yeah, they do.
I can feel it.
Well, that's running. Let's just let that run for a minute. So what we've done is we started adding some auto-instrumentation, and we saw where some of the shortcomings of that were. We enabled the experimental service bus. That got us some more information about the overall flow. But it still wasn't perfect, because there was parts of the system that weren't correlated. What I didn't show you is how we can use the OpenTelemetry collector in Aspire as an Aspire component to then add some more filtering, to remove some of the data that isn't valuable. Saves cost, makes things faster when we're querying things. We also added the Kafka instrumentation. You didn't really see that because it was just, let's enable the thing. We also added some custom spans around the channels so we could get some propagation for the in-memory things.
So that's going to help you see the orchestration. If you're doing it internally, you're going to need to basically be able to tie everything together.
So, yeah, so now we've got these individual spans, these individual traces, sorry. That's one delivery that's happening for one courier. Nice debug context. It still includes some of the other services, look. Storefront workers in there. That's a debug context. What you should be doing when you start thinking about instrumenting your code is what's the context in which I would debug this? But what I can do from here, I can click on this one here. You see this thing at the bottom? Right down at the bottom there. We have a span link. So even though this is its own trace, it has a link back to the original trace, which means I can then, or I should be able to, go back and view the original trace. So I can still get between them. I don't have to rely on conversation IDs and these abstract concepts. I can use the inbuilt stuff in order to do it. So you saw me breaking about that propagation. That was that last one. So we can now build our own debug context, make it easier for people to keep things in their head. That flow there is 3 services. There's about 8 or 9 different interactions that happen across 3 services. Think about your system. If you've got an event-driven system, is it more than 3 services? Is it more than 9 interactions? Is it going to be one trace like that that's hard to debug? You should be breaking it apart. In conclusion, it's not one view.
And that includes both static and dynamic, right? All of these tools are useful for you, but the static tools are much more helpful when you're thinking about the requirements of what you need to build. Once you're trying to build that, as I discovered, I can come up with all the static diagrams to share with Martin about what I intend to build for us, but it doesn't help me find what's actually the problems at runtime. And that's critical to us actually delivering.
Yeah, and it's about marrying up the thing that your architect sent you and says, this is what it should do, and then the thing that the engineer created, the architecture diagram, says, this is what I built. It's marrying those up with the SREs who go, but it doesn't do any of that. It looks like this. They're all useful things. Don't think that one view is enough. Don't think that auto-instrumentation is enough. Go away and instrument your code and spend some time. That's what we're really trying to get across. Look at the demo. It's on Ian's thing. We're going to go to the particular booth after this.
Shop.
We're going to go to the particular booth after this if you'd like to come and have a chat. And we'll be around there just to, be around for the rest of the day as well. But hopefully you've got a bit of information. Ian's got some talks on messaging. I've got some talks on OpenTelemetry, which go into more of the OpenTelemetry concepts and what you can do. The goal of this was really to inspire you to actually do the work. Don't think 3 lines of code is enough. Yep. And that's it.
Cool. Thanks very much for coming, and sorry we overran.